Okay, so what I'm going to do here is show you how to use your TI-84 graphing calculator to find the confidence interval to estimate the population mean when you're given the sample standard deviation. In other words, the population standard deviation is unknown, and therefore you're going to use the student's t-distribution as your sampling distribution. So this example is in your notes for this week, which is week 10 in Blackboard, so you could go open that up if you'd like. All right, so this question says the owner of Grade A Egg Farm wants to estimate the mean number of eggs laid per chicken. Now, I don't know how many chickens are on an egg farm, but I would imagine hundreds of thousands, and you can't possibly, ask them every day, gee, how many eggs did you lay today? It's probably an impossible feat to do. So if they're going to, give you any answer as to, on average, how many eggs their chickens lay per day, per month, or what have you, they're going to have to take a sample. So it says a sample of 25 chickens, so there's your N, shows they laid an average. Now, these 25 chickens laid an average of 20 eggs per month. That's a sample mean, sample average. And here's the key phrase, with a sample standard deviation of 2 eggs per month. In other words, those 25 chickens, those 25 pieces of data, gave me that mean, so that's a sample mean, and gave me this standard deviation of 2. That's a sample standard deviation. Okay. Letter A says, what is the value of the population mean? All right, well, obviously, if we knew the answer for the population mean, then what on earth would we need to estimate it for with a confidence interval? The value of the population mean, we don't know what it is. And you know what? We probably never will, because we don't have the time to ask, hundreds of thousands of chickens, how many eggs did you lay this month? So this is kind of a trick question. It really is. What's the value of the population mean? We don't know, and we probably never will. But it says, what's the best estimate of this value? Well, right now, you want me to point out a number? I'll point out one right here, 20. It's the best I could do right now. But, we know that 20 is probably a little bit off from the actual mean of all the chickens, right? So this mean is only based on 25 chickens. So if you want me to point out a number, it's called the point estimate. This is what we call the best estimate of this value. I'm going to say x bar equals 20. All right. Explain why we need to use the t-distribution. All right, well, plain and simple. We're given the sample standard deviation. The population standard deviation is unknown. When you don't know the population standard deviation, you are going to use the t-distribution with n-1 degrees of freedom. There are 25 pieces of data. That means there are 25 minus 1, which is 24 degrees of freedom. So it says, for a 95% confidence interval, what's the value of the critical t-score? All right, so think about it. This is a 95% confidence interval. There are 25 chickens. That means there's 24 degrees of freedom. So if I go to my t-table, so here's the t-table here. So remember that this is not one particular t-distribution. This is several t-distributions. So how you read this table, it's pretty simple. Here's your 1% stuff. Here's your 5% stuff over here. In other words, 99% confidence over here. 95% confidence over here. And then whether you have one-tail or two-tailed distributions, now confidence intervals that we calculate in this class are always two tails. Not every confidence interval is a two-tailed confidence interval. There is a such thing as one-tailed confidence intervals. We just don't calculate them in Stats 1. So when you're asked for a confidence interval, it's going to be two tails. All right, so we're going to be looking over here. Alpha is 5%. In other words, 95% confidence, and we're going to be looking down this two-tailed column. The only other thing I need to know is degrees of freedom. All right, we already discussed that. There's 24 degrees of freedom. So there's 24 right there. So you follow straight across. Looks like plus and minus 2.06. So that's my critical t-score. All right, so that is, oh yeah, it asks for it over here. For a 95% confidence interval, what is the value of the critical t-score? All right, we got that. The critical t-score is plus and minus 2.06. All right, letter C. Go ahead and get me the 95% confidence interval. All right, well, listen, that's a two-step process. You crunch the error, which this time the error formula knows is a little bit different than the last one you looked at. The last one we studied, that said Z sub C right here, and that little S said sigma, right? Because we use the normal distribution when we know sigma, the population standard deviation. So this error formula is a critical t-score and S divided by radical n. So you plug and chug and you get the error. You take that error, which is 0.0824, you add it and subtract it to the sample mean, which was 20. So remember, the sample mean was 20, right? So you take that error and you add and subtract to the sample mean, creating your confidence interval. All right, so remember the beauty of the calculator. It'll find the error, it'll look up this critical t-score for you, crunch the error, and crunch the confidence interval all in the same step. So remember, to get there, if you're at your home screen here, this thing just crashed on me. Let me reopen it. All right, so you go to your stat, move over to tests. Now number 7 was z-interval. That's confidence intervals for the normal distribution. You scroll down to number 8. There it is, t-interval. So that's confidence intervals for the population mean using the t-distribution. So you select that option. First thing it asks you, what are you going to give me? Calculator wants to know, you give me data or you give me stats? Well, we have stats. So you hit enter, notice how the inputs changes. All right, so x bar 20. The sample standard deviation was, I believe, 2. Yep, 2. The number of chickens was 25. The confidence interval is 95%. Okay, calculate. Notice how it takes a little bit more time to crunch it. All right, so here it is, 19.174, 20.826. Now, if you look at it how I did it, by hand, 19.176, 20.824. And you're like, wait a second, the numbers that we got over here are a little bit different than the calculator. Well, actually, there's a reason for that. If I go to the distribution menu above vars, and you've learned how to use inverse normal. That's how you backwards look up a z-score. There's, if you have a TI-84, it has this option called INV-T. And what that will do, this INV-T right here, is this table. It'll just look it up for you. You just have to know how to use it. So in actuality, if I asked the calculator, hey, go get me this t-score, which remember, we got 2.06, which is over here somewhere. It needs 2 inputs, inverse t. Inverse t needs area on the left of your t-score. Now think about it. If you have a 95% confidence interval, let me see if there's a picture. Yeah, there is one right here. If the area in the middle here is 95%, then the 2 tails, this little tail and that little tail, they get the other 5%. That means each of these tails gets 2.5%. So if you want, say, this t-score right here that cuts off that little tail, the area to the left of that t-score is 0.025, which is 2.5%. So that's the first thing this function needs. It needs area on the left. The second thing it needs is degrees of freedom, which were 24. Now watch what happens when I ask the calculator, hey, go look up this t-score for me. Notice we got 2.06, positive and negative. Well, the calculator's answer, much more accurate, as you can see. And because it's more accurate, obviously the confidence interval is a little bit different. So when I went back to stat, tests, number 8, and I asked it to calculate the confidence interval for me, and I got that answer, and then I look at the answer I got by hand, and by hand I mean I grabbed this 2.06 from the table, and what ends up happening is, you get an answer that's a little bit different. In actuality, the calculator's answer is probably a little bit better because the t-score is a little more accurate. Well, not a little more, it's a lot more accurate. This t-table is only accurate to 2 decimal places. I think the one in my math lab is accurate to 3 decimal places. It's a little better than this one. But the TI graphing calculator has it accurate to 10 decimal places. Now, if you have an old-fashioned TI-83, unfortunately, when you go second vars, you're not going to have that INV-T option. You'll only have INV-norm. So, these 2 features, INV-norm and INV-T, those will get you all your critical z-scores and your critical t-scores if you don't feel like using tables. But, it's not a big deal. Pulling out this table is not the end of the world. All right, so let's see what else I got here. So we have that. Then it says, would it be reasonable to conclude that the population mean is 20.5? All right, well, yeah, sure. 20.5 lands inside my confidence interval. Looks pretty good. What about 25? Well, 25, not so much. I mean, that lands way outside, right? So 25 does not land in your 95% confidence interval. Therefore, I would say that is not a reasonable value. Okay, I hope this helps. Email me if you have any questions. Take care.